G'day lads, in this video I'll take you through how to build a spreadsheet to predict NRL games and generate probabilities for the head-to-head, under-over points, margin and line markets. If you want to save time and download this spreadsheet so that you can use it for every NRL game in a season, then click the first link in the description below to become a member of the Excel Lads on Patreon. It'll also come with a futures model so that you can analyze your team's chances of winning the competition at any stage in the season, including the finals. Let me know what other video ideas you have in the comments below. And before we begin, thanks for watching, lads. So the first step, lads, is to start with a blank worksheet, and I'll name this 2025, or the season you're in, NRL draw. And in here, you're going to have the list of fixtures as well as the score and information for all the games. So from column A to the right, you'll have the headers: date, stadium, round, home and away team, home and away score for that game, and then the tries, conversions, penalty goals, and field goals. Unfortunately, unlike other spreadsheets built on this channel, there's not a data set to connect to automatically through a Power Query in Excel, so we'll have to write the data in manually ourselves at the end of each round, and that's what I've done here. I've copy and pasted all the data so far this season. That includes fixtures for every game and scores for the games that have been played. So the Storm vs Sharks game hasn't been played yet for me while filming, so I've left that blank, but the remaining games in the season for the date, stadium, round, home and away team have been filled out all the way through to the Eels versus the Knights in round 27 at the back end of the season. Next, I'll create a new worksheet called 2025 NRL Draw Adjusted, and in here we're going to adjust the 2025 NRL Draw worksheet we just made so that score lines that have been blown out of proportion, such as 60-0, 58-10, are adjusted so that a team's true strength isn't unfairly impacted moving forward, say after a 60-0 win or loss, because that's often not representative of a team's true strength. Those score lines blow out into numbers that aren't representative of a team's true strength. So that's what we'll do in this worksheet. Copy in the row headers in row 1 from the 2025 NRL draw worksheet into this new draw adjusted one. And then in cell A2, make it equal to A2 in the 2025 NRL draw worksheet. Make sure to change columns F through to O into a general format along with column C. That might have to be something you'll do. And then with all these columns, drag that formula all the way down to row 205, which will be the last game of the season, Eels versus Knights. It's the exact same as the other worksheet, except for games that haven't been played yet. Instead of showing a blank cell, it'll show a 0. Now the change we'll make is in columns H and I. You'll see for this Storm Eels game, the Storm beat the Eels 56-18. Now that might unfairly impact the Eels moving forward with their defense, because if a team scores 4 tries in a row, a defense might give up, they might get too tired, and so they'll concede more tries than what they should in a more even contest, relatively speaking. So the formula we'll use in H2 is going to be equals if NRL draw H2 minus NRL draw I2 is more than 4, there's more than a 4 try difference. Then if that's true, do NRL draw I2 plus 4. If not, keep it at H2. And so for that Eels Storm game, the Storm's tries have now been reduced from 10 to 7, so that there's a maximum difference of 4 tries between the two teams. We'll do the same thing for I2. If I2 minus H2 in the 2025 NRL draw worksheet is more than 4, return H2 plus 4. If not, return the original NRL draw I2. And then drag that formula down to the last row, 205, so that it is applied to every single game. Now that we've done that, we can create a third worksheet, and in here we can name this NRL ladder. And as you can probably guess, we'll create a ladder so that after each new game we input into the 2025 NRL draw worksheet, the ladder updates and you can see a team's live position throughout the season. So I'll put the headers team played, points, wins, drawn, lost, buys for, against, points difference, home and away, and point percentage in column O there. And for the list of teams, you can just use the unique function for all the home teams in the NRL draw worksheet. And there should be exactly 17 of them. So you can either use that unique function or simply write out the teams yourself. So that from C51 to C67, you've got the 17 NRL teams in any order you like. It doesn't matter as long as they're fixed and they're there. Now in column D, we need to get the number of games each team has played so far in a season, and we can do that using the sum product function. So using the double negative at the start of the first argument, I'll collect D2 to D205 and make sure that it picks up all the instances of the home team being equal to C51, which is the Canberra Raiders in this row. And as I put a $ in front of only the column, as I drag it down, it'll pick up rows 52, 53, all the way to the bottom. The next argument, multiply that so that it is required that F2 to F205 in the 2025 NRL draw worksheet is not equal to nothing. So it's not blank. So close that bracket, close it again. We'll copy and paste that sum product function into a new one so that we change it to pick up the away sides in column E to make sure they're equal to C51. Leave the column F argument. We can press enter, double click to drag the formula down to row 67 for the Titans last there. And now we've got each team's games played. We can use this formula to work out the number of wins, draws, and losses they've had in the season. With the wins formula in column F, you're going to use the sum product function where you'll use the double negative at the front of the first bracket again. And the first argument is going to be whether D2 to D205 in the 2025 NRL draw worksheet is equal to C51. So picking up when the Raiders are the home team, multiplying that so that the next argument has to be true. With F2 to F205, again, being not equal to, defined by less than and greater than sign put together, nothing, defined by the double speech marks there with nothing in between them. And the last argument is multiplied by NRL draw F2 to F205 being greater than G2 to G205 in the NRL draw worksheet. That picks up how many times the home points is greater than the away points, how many times column F is greater than column G. And we'll copy and paste that formula to add the same thing again, but this time we'll change D2 to D205 to E2 to E205 and switch the F with G and vice versa in the third argument to pick up how many times the away side score more points than the home side. So we'll drag this down to row 67 as well. And to calculate the number of drawn and lost matches, it's really easy. It's basically the same formula, but with that third argument in the two sum product functions, we've got to change it to an equals and a less than instead of a greater than sign. So greater than goes to equals, and same thing for the away sides. Drag that down to 67. And then this time you're just swapping the greater than with a less than sign. So very straightforward. Press enter on that, and then you can drag that down to row 67. Now, the last column to calculate before getting the points for each team is the number of buys a team has had so far in a season. And to do that, we'll have to use a let function with the first name being rounds underscored played. And we'll define this using a max function. Within that, an if function. It's going to be if F2 to F205 in the 2025 NRL draw worksheet is not equal to nothing or double speech mark. Then we're going to return the C2 to C205 range in the 2025 NRL draw worksheet. And if not, we'll just leave that blank. Close the brackets twice. The next name will be number of games. And in here, I'll use a counting function with the range of C2 to C205 in the 2025 NRL draw worksheet. And I'll absolute reference that by putting a $ to fix both the column and row in this range. with a criteria of speech mark less than or equal to speech mark ends rounds underscore played. Close that bracket. The next calculation will be home underscore games. And in here, I'll use another county function. Again, this will have data in 2025 NRL draw, this time from D2, absolute reference that cell. And then the second part of that range will be defined by an offset function with a reference of D2, a number of rows equal to number underscore of underscore games minus 1, and comma 0 for the columns. Close the bracket. The criteria is $C51. And I'll do a very similar thing for the away games, except this time the range will be the list of away teams from E2 to again an offset function with a reference of E2, a number of rows equal to number of games minus 1, and columns equal to 0. Again, the criteria, it has to be equal to the team in C51 of the NRL ladder worksheet. Close the bracket. Now, our final formula is going to be rounds played minus home games minus away games. And that will give us the number of byes each team has had so far in the season, which are worth 2 points in the NRL. Drag that down to row 67 and it becomes very easy to calculate a team's points from here. It's just the number of wins times 2 plus the number of draws times 1 plus the number of byes times 2. When I drag that formula down to cell E67, I can then move on to the for and against columns. And to do that, I'll just copy and paste the formula from F51 into J51 and remove the greater than G2 to G205 from the first sum product and the greater than F2 to F205 for the second sum product, instead of finding the number of times the home team beats the away team for home teams and vice versa for the away side. I'll just sum the home points scored by home teams with the away points scored by away teams for each team from row 51 to row 67, and I'll copy and paste the same formula into K51, but this time I'll count the sum of the away points when home teams are playing and the home points when away teams are playing, so that I get the points conceded for each team, and that's the sum throughout the whole season. Now for the points difference in column L, it's just column J minus column K, very straightforward. Now the home and away columns here will just be each team's record at home and away. So for M51, I can copy and paste the first sum product function in the wins formula, and that'll be equal to 6 for the Raiders. So they've won 6 games at home so far this season. Now I've got to get the formula for the number of games they've lost at home this season. That's the first sum product function in H51. And I'll join those two together using an ampersand, speech mark, space, hyphen, space, speech mark, ampersand, and paste a second sum product. So I get each team's home record, and then it'll be the exact same process for the away record in column N. I'll get the second sum product function for wins. So that'll be the number of times a team wins away. And I'll get the second part of the lost function, the number of losses they have as the away side. And I'll join those two together using the ampersand as well. So and space, speech mark, space, speech mark, and sum product function. So I'll drag that down to 67 again. And the point percentage is just going to be equal to J51 divided by K51, and I'll drag that down to row 67. That's just to differentiate between teams with the same number of points and points difference. So that's the unsorted ladder done. I can add borders to each cell and make it nice and neat. Now above, I'm going to sort this ladder so that first will be the team with the greatest number of points, and last will be the one with the least. So I can go into cell C3 and copy and paste the headers from team through to the away side. And then in B3, I'll write the text position. Now from B4 downwards, I can list numbers 1 through to 17 using the sequence function, or you can write it out yourself. Now in C4, I need to use the sort function within a drop function to return the teams in order of points, points difference, and P percentage. So I'm going to sort the array C51 to O67, comma, the sort index in those curly brackets will be column 3, column 10, then column 13. I'll go in descending order, close the bracket, I'll drop 0 rows and -1 columns. So if I wait for it to load, then go back up. Now the full list of teams in order of points, points difference, and P percentage has been sorted, and I can format it to nicely show first, last, the top 4, and the top 8 teams who are going to make the finals. Now, whenever I change or add something to the 2025 NRL draw, when more games have been played, the NRL ladder will update. So right now, the Bulldogs were coming second. If I give them a win against the Broncos in round 18 here, say the score is 40-10, what will happen is on the NRL ladder, they'll leapfrog the Raiders into first place. They've played one more game, their points difference, points, every stat updates, and if I delete it, it'll go back to normal. So whatever games you input here, it'll reflect itself in the NRL ladder. Now we can make a new worksheet called Attack and Defense Stats. And in here, I'm going to calculate each team's attacking and defending strength for tries, penalties, as well as get their conversion success rate. These 3 parameters will be crucial in simulating a matchup between 2 teams. So from B2 across, it'll be the team, games, tries per game, tries against per game, penalty goals per game, and penalty goals against per game. Then from B3 downwards, I can copy and paste the list of teams from the NRL ladder worksheet. Then I can make this table presentable before I calculate the number of games each team has played in column C by using an XLOOKUP function, where my lookup value will be the team in B3, and I'll look up that value within the array C51 to C67 in the NRL ladder worksheet, and I'll return the games played beside it from D51 to D67. When I press enter and drag that formula down to the last row for the Gold Coast Titans, I can then calculate the number of tries scored per game by each team by first returning the number of tries each team has scored throughout the season and then dividing by their number of games played. So to find the number of tries, I'll use a sum product function. Open the bracket, 2 negatives, open the bracket. First array will be D2 to D205. And I'll make sure that is equal to the team in B3. So $B3, so I can drag down, multiply that by open bracket, F2 to F205, the home score, and that needs to be not equal to a blank value. So a game has to be played for it to count. And then I'll multiply this argument by the number of home tries from H2 to H205, and this will sum the number of tries the Canberra Raiders will score as the home team. I need to add the number of tries they've scored as the away team to get their total number of tries in total for this season. So the sum product function will basically be the exact same thing. Instead, I can change D2 to D205 to E2 to E205, as now we're counting the number of times the Raiders are the away side in column E. I'll multiply this by, again, the same argument. F2 to F205 has to have a value in it. The game has to be played. There has to be a score. And then I'll multiply this by the number of away tries in column I. So I2 to I205. Absolute reference this, close the bracket. And then now, after you close the bracket 3 times, I have 73, meaning the Raiders have scored 73 tries so far this season. And to get it per game, very easy. Divide by $C3, the number of games, 16. And that yields 4.5625. I can drag that down for every team. And then to get the tries against per game, it'll be very similar, except we'll flip some values. So instead of it being the number of home tries scored by the home team, I'll change H to I to pick up the number of away tries when Raiders are the home team to count the number of tries conceded, and vice versa. So change I to H and H to I, and then drag that down to get the number of tries against or conceded per game by each team. Now, copy and paste the formula in D3 into F3, or you can drag E3 across. It doesn't matter. We're only changing the third argument in each of the two sum product formulas. Here, it'll go from I2 to I205 to L2 to L205, and then the second sum product function has to have M2 to M205. So drag that down, and then you can drag F3 across, and L2 to L205 is swapped with M2 to M205. So swap L with M and swap M with L before you press enter, just as we did for the tries for and against. We can drag that down, and then now we've got a full table. Next, I'll copy and paste B2 into B21 and change the text to average. We're going to calculate the average value for each of these next 5 columns. To get the average number of games for each team, very simple, average C3 to C19. Next, we can find the average tries per game by finding the sum of the total tries scored in the competition divided by the number of games played. So to do that, we can use the sum function and go into the 2025 NRL Draw adjusted worksheet and go H2 to I205, picking up both the away and home team tries in those two columns. And then we'll divide this by the sum of the games played in C3 to C19. And once you do that, we can press enter and we'll get the average tries per game. Now it'll be the exact same result for the average tries conceded per game, and we can do the same thing for the penalty goals per game now. Sum the total penalty goals for both home and away teams and then divide by the total number of games played. So going back into the 2025 NRL Draw adjusted worksheet, we can go into M2 down to, rather L2 through to M205. So the home penalty goals and away penalty goals columns. Close the bracket there, then divide by the sum of the total games played in C3 to C19 of the attack and defense stats worksheet, which we're in right now. Close the bracket, press enter, and then drag to the right to do the same thing for the penalty goals against or conceded per game. So we've got our figures now. We can round them to perhaps 2 decimal places and make sure the table is nice and formatted. With these numbers, we can now find the attack and defense ratings for each team for tries and penalty goals. Before we do that though, I'll just copy and paste B21 to C21 into B23 to define a home advantage. In this model, we'll use 10% in C23, and that'll apply a total advantage of 10% for home teams scoring tries and making penalty goals. So we can begin our attack and defense table in I2 with the headers team, tries attack, tries defense, penalty attack, penalty defense, and then I also need a conversion percentage column to show what percentage of conversions teams will make after scoring a try. So I can make that all a table now. It's a very simple calculation for the tries attack rating. In J3, it's D3 divided by D21. Make sure to put a $ in front of only the row 21 so that we can drag down and across, and it'll fill out for the tries defense, penalty attack, penalty defense, all 4 of those ratings, round to 2 decimal places, and we've got it all now. So an attack rating above 1 is good, meaning they score that try or penalty more often than the average team, but of course you want a low defense rating, ideally below 1, so that you can see less tries than the average team, or penalty goals. Now for the conversion percentage, we'll use a sum product function. Open bracket, sum product, double negative, the first argument is D2 to D205, has to be equal to the team in I3. So we'll sum the total conversions made for home teams in this sum product function. Multiply by, open bracket, going back into NRL draw, F2 to F205 can't be equal to nothing. So there has to be a score, that is the game has to be played. Close the bracket, multiply by, and then our last argument, which has to be true for the row to be counted, is J2 to J205. So we're adding the total conversions made by home teams, or where Raiders are the home team here. And then we're adding the same sum product function, but of course we'll change the home side to the away side to account for when Raiders are the away side. So change D to E and J to the next column to the right, which is K. That becomes K2 to K205. Close the bracket there. This formula so far represents the total number of conversions the Raiders have made so far this season. To find the conversion percentage, we're going to divide this number by the total number of tries they've scored in the season. So we can copy and paste the entire function to become the denominator in this equation and change J to H and K to I. Once you do that, you can press enter, and the Raiders convert 77.3% of their tries, drag down to row 19. And then we've got our attack and defense ratings made up along with conversions. Using these, we can now pick a matchup or a game between two teams, calculate each team's expected tries, penalty goals, from that expected conversions, and we can simulate these to find the probability of each team winning, as well as other markets. So we can create a new worksheet called simulations now in A2 to A3, home and away advantage. Now in B2, the home advantage is going to be the square root of 1 plus the home advantage we defined earlier in the attack and defense stats, 10% in cell C23. Make sure to absolute reference that so we can drag it down to B3. However, for the away advantage, it's actually a disadvantage. We're doing 1 divided by the square root we defined earlier, so that the total advantage for the home team is 10%. 1.05 divided by 0.95 minus 1 is exactly 10%. Now, in A5 to A6, we can calculate the home and away expected tries, but of course, this depends on who the home team is, who the away team is. If the home team is strong, they'll score more expected tries, and vice versa for the away team. So we need to create a dashboard so that we can select our two teams in the match and calculate the probability of all the markets we want to see: head-to-head, margin, line, total, over-under points. So we can set up this template now in B2 to D3, as well as B5 to D6. Merge and center the cells to type in the text home and away. Do the same thing in E2 to K3 and E5 to K6. In here, we'll create a list using data validation in the data tab. The source is going to be the list of teams in the attack and defense stats, B3 to B19. So this will create a drop-down list where we can select our two teams in the matchup, our home and away team. Let's do the Dragons versus the Eels with the Dragons at home. Now, beside it in L2 to M3 as well as L5 to M6, we can merge and center those cells. In here, we'll put the expected points for both teams in a game. And then beside it in columns N and O, we can eventually put the win percentage for both teams. Now, I'll format these cells. Now we can go back into the simulations worksheet so that whatever team we choose, their expected tries, penalty goals, conversions will be calculated in this worksheet, simulated to find the distribution of results. So for the home expected tries, we can use an XLOOKUP function with the lookup value of E2, the home team. Absolute reference that. A lookup array of the list of teams in the attack and defense stats worksheet. that's I3 to I19, and then we can return their tries attack rating from J3 to J19. This will be multiplied by the away team's tries defense rating. So we can look up the away side from dashboard cell E2, rather E5. E2 is the home team. We want to look up the away side in E5. The lookup array is I3 to I19 again, but this time, of course, we're returning their defense rating. The formula is attack rating multiplied by the opposition's defense rating multiplied by the league average tries scored per game in D21. So that's the home tries, but we've still got one more thing to do, multiply by the home advantage in B2 to increase that or scale it up by 5%. So the Dragons are expected to score 4.22 tries here. Drag that formula down to B6, and the only thing we're changing is E2 to E5 and E5 to E2. So now calculating the away team's expected tries, it's the away team's attack rating multiplied by the home team's defense rating, which is what we changed. And we can see the Dragons are 1 try favorites here, 4.2 tries to 3.1. Now I can calculate the home conversion percentage as well as the away conversion percentage. And it's really not even a calculation here because we've already got it. So we're just using an XLOOKUP function to search up who the home team is within the list of teams array in the attack and defense stats worksheet, and then return their conversion percentage we calculated only 5 minutes prior. So look up E2 in I3 to I19 and then return the conversion percentage in column N. We can do the exact same thing by dragging it down and then changing the lookup value to E5, which is the away side. So they both convert at about the same rate so far this season. The last expected value we can calculate is the expected penalty goals for both sides. So from A11 to A12, we're doing home expected penalties, away expected penalties, and this will be the exact same attack defense formula. For the home expected penalties, it's the home team's penalties attack rating multiplied by the away team's penalties defense rating, scaled up by the average penalties scored per game, then multiplied by the home advantage or the away disadvantage when doing the away side's expected value. So return the attack rating in column L3 to L19 for the home side. Now XLOOKUP E5, the Eels, look them up in the lookup array, same as always, I3 to I19, and then return their penalty defense rating. And then, of course, multiply by the average penalties scored per game in F21. And then lastly, scale by the home advantage, 1.05 in B2, so that when we drag it down, that becomes the away disadvantage, and we can swap E2 with E5 and vice versa. Press enter, round to 2 decimal places, and we have got all the values we need now to simulate a game between the Eels and the Dragons. So in E1 and F1, put the home and away team respectively. Then from D2 downwards, we're going to put the labels tries, conversions, penalty goals, score, golden point winner, and final score. So that's what we'll calculate from E2 to F7. Now, to simulate the number of tries the Dragons will score, we'll use the binomial distribution, the binomial inverse formula with 10,000 trials, comma, the probability of success is the number of expected tries divided by 10,000, comma, rand for the alpha, use a rand function. So now when I press backspace and simulate a new game, the Dragons have their expected tries simulated. We can use the same binomial inverse function for the Eels, 10,000 trials, probability of success is the expected tries divided by the number of trials, 10,000. Alpha is the rand open bracket close bracket function to simulate it. That's the simulation property in the function. And so now we have simulated the number of tries each team has scored. To simulate the number of conversions, well, conversion comes after a try, so we've got trials equal to the number of tries scored, a probability of success equal to the conversion success rate, and use the rand function to simulate it. So if the Dragons have scored 5 tries in this one, they've converted 4 attempts. We can do the same thing for the Eels, the away side. The number of trials is equal to the tries in F2. The probability of success is their conversion percentage. the simulation properties, the rand open bracket, close bracket function. Here the Dragons have scored 4 tries, converted 3. The Eels have scored 3, but converted all 3. Penalty goals are simulated in the same way as tries. 10,000 trials, B11 divided by 10,000 is the success rate, and then rand for the simulation. Binomial inverse 10,000, comma, away side expected penalties divided by 10,000. Alpha is rand function, close the bracket, press enter. And from this, we're able to get a regular time or 80-minute scoreline. That's equal to the number of tries scored times 4, plus the number of conversions in E3 times 2, plus penalty goals times 2. Press enter, and then we can drag that across to column F for the away side, and we've got our simulated 80-minute score for both sides. And in the unlikely event, it happens about 5% of the time for most games, that the scores are tied after 80 minutes, we've got to do or perform a simplified golden point winner simulation using an if function. If the rand function is greater than 0.5, let the home side in E1 be the golden point winner, otherwise let F1. So in this model, if both scores are tied after 80 minutes, a random team, each with a 50-50 chance, will receive an extra point, meaning they're the golden point winner. In cell F6, we need to show whether the game was finished as a draw or it was final after 80 minutes, if it wasn't. So if E5 equals F5, then draw. If not, then it's the final score. Now, to calculate the final score of the game, including the potential golden point winner, if the 80-minute score is tied, we'll use an if function. If E5 is equal to F5, then use another if function to determine whether E6 equals F or E1. If E6 equals E1, the home side, then return E5, the home score, plus 1, because they're the golden point winner. If not, return E5, the normal score. If not, return E5. Close the bracket there, and then we can do the same thing for F7, the away side. If E5 equals F5, then return an if function, whereby if the golden point winner is equal to the away side in F1, then return the away side's 80-minute score plus 1 because they're the golden point winner. Otherwise, return F5 by itself, otherwise F5. Close the bracket. Then we get the final score here. So we can run simulations as many times as we want by clicking the backspace button on an empty cell. But in order to see the distribution of results, we've got to perform those simulations at the same time and then analyze them and record their results. So to do that, we can perform a Monte Carlo simulation. I1 and J1 will be equal to dashboard E2 and E5, the home and away team, and K1 will have the header 80-minute status. From H2, we'll put the header trials, and in H3, we'll spill numbers 1 through to 5,000. They'll represent 5,000 trials we'll perform of the final score between the two clubs. I2 will be equal to E7, J2 will be equal to F7, the final scores, and the 80-minute status in K2 will be F6. Now, to perform 5,000 trials of that, we can select H2 through to K5002, go into the data tab. In here, go into what if analysis, and we'll run a data table. Skip the row input cell for the column input cell, just put a cell outside of the data set we're not using, such as N7. Press OK. It might take a few seconds to load because 5,000 simulations is a lot for Excel. But when it does, 5,000 games between the Dragons and the Eels will appear. That'll update based on what teams you select. So if we go back into the dashboard worksheet and select 2 different teams, these 5,000 simulations will change based on the parameters such as expected tries, penalty goals, and all that. So those simulations are done now. We can build formulas to analyze them for the matchup selected now back in the dashboard worksheet. Now for columns L and M, for these 2 cells, we can calculate the expected points for both sides by using the formula expected tries times 4 plus expected tries multiplied by the home conversion percentage times 2 plus expected penalties times 2. Press enter on that. Again, you'll notice it takes a couple seconds after pressing enter because of the 5,000 simulations Excel has to perform. If we go back into the simulations worksheet, we can see the average of the 5,000 simulations is 24.934, very close to the expected points for the Dragons. And due to the law of large numbers, the more simulations you perform, the less variance there'll be, and the closer to the true mean that result will be. So we can perform the exact same formula, but for the away side in cell L5. And the Dragons have about a 6-point advantage over the Eels in this matchup at home. In N2, we can calculate the probability of the Dragons winning using a sum product function to count how many rows the Dragons simulated score was greater than the Eels. So simulations I3 to I5002 have to be greater than J3 to J5002. And then I'll divide by the number of trials, 5,000, to return a probability. When I press enter on that, I get a decimal of 0.672, meaning the Dragons won about 67.2% of the time across these 5,000 simulations. If I copy and paste the formula into N5, I can change the greater than to a less than to indicate the number of times the Eels won and find a probability based off that. You'll notice when I reran these 5,000 simulations to find the Eels' chance of winning, the probabilities changed. Now, the expected points don't, because that's a set formula based on attack and defense ratings, but the nature of simulations is that they're random. So because we're only performing 5,000, there'll be a standard deviation of about 1% across those 5,000 trials. So in this situation, even though the Dragons are expected to win and should have a probability, or do have a probability, above 50%, in this batch of 5,000 simulations, the Sharks actually won slightly more. And this is just due to random chance. That rand function we put as the last argument in the binomial inverse function to simulate the number of tries and penalty goals scored. So if you want to increase the simulations to reduce the standard deviation and variance of the probabilities we find for all the markets we're going to find now, then you can do that however many times you want, but it will come as a cost of Excel will not load as quick. Right now it takes about 2-3 seconds to load the 5,000 simulations, and it would be proportional to that if you increase it by double or 3 times. So we can find the probability of the head-to-head markets by using the win percentage in N2 and N5, which we've already calculated. So after you've done all this formatting in cell B11 and B12, that's going to be the home and away side selected. The win percentage is going to be N2 for the home side, in this case Raiders, and then below that the win percentage for the Sharks is going to be N5. Now the value is what is fair value. So in Australia we use the decimal form of odds. So that's equal to 1 divided by the win probability. And in this case, it's 1.48 right now for the Raiders. So if a bookmaker was offering odds of $1.70 and this was your strategy, simply just purely using this model, now the value is $1.49, then that would be a bet with a positive expected value. If the bookmaker was only offering odds of, say, $1.30, then you wouldn't take that bet. Now we can calculate the market for the total points over and under. In K11 over, K12 under. Now the formula to find the probability of the over and under markets is dependent on the points threshold set in N14. Right now we'll put it at 45.5 points for the entire game. To find over, we're going to find the number of rows where the sum of both the Raiders and the Sharks points scored is above that threshold. So that's I3 to I5002 in the simulations worksheet plus J3 to J5002 is greater than N14 in the current worksheet. Again, absolute reference this so we can drag down for the under market and divide by the number of trials, 5,000, to get a probability. And once you do that, we can drag down, and the only change we have to make is changing the greater than sign to a less than sign to calculate the under points market. So press enter on that. We'll then change it to percentages with 2 decimal places, and the value formula is always the same, 1 divided by the win probabilities, and that will yield the fair value of the market. Now for the margin, we have to create 3 more rows, and in here we'll calculate the odds of the home side winning 1 through to 12 or 13 plus, the away side 1 through to 12 or 13 plus, and the draw market. So all these markets are defined as of 80 minutes. They don't include golden point. So B19 will be equals E2 ampersand speech marks by 13 plus. Same thing for B20, except that it's going to be by 1 to 12. Text draw in B21, and then B22 and B23 the same thing, but for the away side selected in E5. Now for the win percentage, we'll use a sum product function. It'll be straightforward for rows 19 and 23. It'll be going back into the simulations worksheet. I3 to I5002 has to be greater than J3 to J5002 plus 12. And that means it counts every single time the home team beats the away side, who are given a 12-point advantage, meaning how many times the Raiders win by 13 or more points. So press enter on that, and we'll get a win percentage of about 35% for that market. We can then copy and paste this formula into row 23 for this column, and it'll be nearly the exact same thing, except we'll swap the home side with the away side. So I3 to I5002 goes to J3 to J5002, and similarly we'll swap J with I for the other array there. Press enter on that, and then we have a 10% chance of the Sharks being 13 plus in this match. Now we can calculate the chance of the Raiders and Sharks, the home and away team, winning by 1 through to 12 points. And this will have a couple more conditions. So the first condition is I3 to I5002 minus J3 to J5002 has to be less than 13. So the difference can't be more than 13 or greater than or equal to 13, because that covers the other market. We then have to multiply this argument by I3 to I5002 being greater than J3 to J5002. That counts how many times the Raiders or the home side wins. So now this collects the number of games where the Raiders win 1 through to 12. But then we have to make sure that K3 to K5002 is equal to final. So in cases where the Raiders are given an extra point through golden point, we want to exclude that and leave it in the draw market in row 21. So that's what we do by making K3 to K5002 equal to final. Divide by 5,000 trials, and then we can copy and paste this formula into row 22. Here we'll just do the exact same thing as we did before. We'll swap I and J, the away side with the home side and vice versa. Every instance of I swap with J, every instance of J swap with I. Great, so we've done that now, press enter. And then all we've got left is calculating the draw probability in row 21. And to do that, we'll use a COUNTIF function, very straightforward. In simulations for the range K3 to K5002, we want to count how many times the draw 80-minute status appears. So put that in speech marks and close the bracket after putting a $ in front of both the row and column just to keep it consistent with the other formulas. Press enter, and of course you have to divide by the number of simulations, 5,000, to get a probability. And when you do that, the sum of E19 to E23 has to be equal to exactly 100% or 1. If it's not, then you've got some formula wrong along the way. All of these markets, the total sum of the win probability in columns E and columns N always has to be 100%. Otherwise, you've made an error. So now we can calculate the line probability, and the line inserted into N22 is the advantage or disadvantage given to the home team. So K19 is going to be equal to E2, and below that in K20, that's E5. Now to find the probability of the Raiders or the home team winning given the advantage or disadvantage given to them in cell N22, we can use the sum product function. In the simulations worksheet, we'll count how many rows where I3 to I5002 plus the advantage given to them in N22 is greater than J3 to J5002. Close the bracket twice, then divide by the number of trials, in this case 5,000, and we have to absolute reference this formula by putting a $ in front of both the row and column to fix that range when we drag it down. Press enter, and here we get a probability of 50.4% in the bunch of 5,000 simulations performed for the Raiders, covering the line of 7.5 points. Without running this formula, you could already kind of tell it's 50-50 due to the fact that the difference between the expected points between the Raiders and the Sharks in L2 and L5 is already about 7.5 points, so it's going to be 50-50. Copy and pasting into N20 below, we have to swap I with J, and we need to subtract the line in N22. So swap I with J and vice versa, subtract N22 the line, press enter, and the probabilities update. So we can turn that into a percentage and copy the value formulas in. And then once you do that, that is pretty much the model completely done. So we can test it out by selecting two separate teams and seeing how the probabilities update. Before that, you can go into page layout and remove grid lines by unselecting the view checkbox so it looks a bit neater. If I change the home side to the Roosters, all the markets and the probabilities update due to the 5,000 simulations being rerun. I can change the away side again to the Broncos, and you can do this for every NRL game, every round, given the data entered into the 2025 NRL draw worksheet. So you just have to make sure that worksheet is updated with the newest games, and then you can forecast these four markets, being able to change the line as well as the total points over or under, depending what's offered by the bookmaker for that game. Thanks for watching, lads. If you want to download this model so you can use it on every game in a season, then make sure to click the first link in the description below to become a member of the Excel Lads Patreon.